Welcome everyone, and today we are going to be reviewing angle relationships inside and outside circles, and also on circles. This is from Module 2, Topic 2. So let's go ahead and jump in. There are basically three formulas or relationships that are found from angles on inside and outside circles. All right? Because there's three places that an angle could go. If I sketch a circle here, one of the very first angle relationships that we're going to talk about is when our angle is on the circle. Alright, so when our vertex is on the circle. Remember, the vertex is the point of your angle where you would measure the degrees. So if our vertex is on the circle like this, then we've just got two chords somewhere else to create your angle. Here is our relationship. Your angle is equal to your arc divided by 2. Alright, another way you could think about it is your arc is equal to 2 times your angle. Alright, so the way that you're gonna see it is if this is your angle and this is your arc. I'll go ahead and show you guys a couple examples before we move on to the next relationship. Alright, so I'm gonna draw some examples underneath here. We'll do 2 examples. Alright, so let's say we've got something that looks like this, and let's say we know that this is 38 degrees. Can you guys see that okay? Not really. I'm going to see if I can zoom this in. Alright, that might be a little better. So this is 38 degrees. Alright? So if we know that our vertex is on the circle, to find our arc, we're going to take 2 times our angle. So if we know that our arc is equal to 2 times our angle, all we're going to do is plug 38 in place of that angle. Alright? So, what would our arc be? How many degrees? That's right. 76 degrees. Okay, let's try another example. Okay, let's say, now this one might look a little different. Let's say that we've got a tangent line. Remember, a tangent line just runs off a circle and only touches in one place. But that one place it touches is still on the circle, right? Let's say we've got something that looks like this. And we know that this is 94 degrees. and we're going to find both arcs of the circle. All right, we're going to find x and we're going to find y. All right, so basically pick a letter and solve for it first. I would solve for the x first since it's on the same side of the circle as the 94. Now this 94 is our angle. That's the angle we're given, and we want to find the arc. So again, arc equals 2 times our angle. So 2 times 94 is going to give us, what's that? 188. So this x is equal to 188 degrees. All right, now how would we find y over here? We've got a full circle, right? So how many degrees are in a full circle? 360. So if I take (360) minus what? The 188 was part of our circle. That's going to give us our y. So, what is our y? Sorry, I don't want to make any mental math errors, so I'm going to get out my calculator. 360 minus 188 is 172. There we go. And we've solved for both x and y. Now, if I wanted to find out the number of degrees down here, how do you think I could do that? Yeah, I could take 172 divided by 2 and get the angle down here. So if I do that, I'm going to get 86 degrees. Okay, so there's our first relationship, an angle that is formed when the vertex is on your circle, and your relationship is always going to be right here. It's just a matter of multiplying by 2 or dividing by 2. All right, the next relationship that we're going to look at is when your angle is inside, your vertex is inside your circle. All right, so I'm going to move this page. If anyone needs to pause or freeze, then go ahead and do that now. All right, so our next one, we're going to have our vertex is inside the circle. So here's how that looks. I'm going to focus this. Yeah, that's a little better. Draw a circle here. When your vertex is inside, that means you're basically just going to have 2 lines crossing inside your circle. So it might look something like this. This could be a secant, and then you could have a chord, as long as they're crossing inside your circle. Just like that. Alright, now, the way that we would find our angle or arc relationship here is, depending on what it is you're solving for, let's say I'm looking right here at this arc, and I'm looking right here at this arc. Arc and arc. These are the intercepting arcs, and this angle right in here is in between. So our relationship is always going to be angle equals arc plus arc divided by 2. All you're doing is you're averaging the arcs to find your angle. Okay? So let's take a look at a couple examples. I'll go ahead and just do that one for right now. And we've got something that looks like this. Okay. There's our x. We know this is 202 degrees, and this is 54 degrees. Alright, so making sure that the angle we want, here's the angle we want, it is in between the 54 and the 202. So if we have angle equals arc plus arc divided by 2, x is our angle, one of our arcs is 202, our other arc is 54, and then we're going to divide that by 2. Order of operations, we can go ahead and add these first. So x equals 256 divided by 2. So that means x is going to be equal to 128 degrees. There we go. 128. So that's how we would find our angle inside a circle. What if we had a problem that looked similar but is just a little bit different? Let's take a look at one other example like this. My circles are getting worse and worse. Alright, our next example, we're going to have something that looks like this. We know this is 26. We're going to say this is 100 degrees, and we want to know what this x is. Alright, this time we know our angle, and we want to find this missing arc on the circle. So, again, here's our arcs, and then this is our angle. So if we use the same formula, your angle is inside your circle, so we're using this formula. Arc plus arc divided by 2. What's our angle? 100. What's one of our arcs? X. What's another arc? 26. X plus 26. You could also say 26 plus x, that's the same thing, and then divided by 2. Now, I want to get x by itself. To do that, I need to get rid of this fraction. How do I get rid of that 2? We are going to multiply by 2 on both sides. Alright, so now we have 200 equals x plus 26. How are we going to get x by itself? Subtract that 26. So 200 minus 26 is 174. There's your x. There we go. Just like that. Okay? So, again, whenever your vertex of your angle is inside your circle, you are always using this relationship. Angle equals arc plus arc divided by 2. Okay, last one. All right, this last one is when your vertex is outside the circle. Vertex is outside the circle. So here's our example of what that looks like. There we go. It could look something like this, where right here is your angle that is outside your circle. And then this is an arc. And this is a little arc, right? Little arc, because it's small, it's kind of short. It's closest to your x. And then on the other side, we have another arc, and it's much bigger. This is a big arc. Alright, your relationship here is the exact same formula we used before, only now we're going to be subtracting, alright? So your angle is equal to your little arc sorry, I messed that up. Your big arc, it's always your big number first, because then we're going to be subtracting the little arc. Let me go over this real quick. Angle equals big arc minus your little arc divided by 2. Alright, that is always going to be your formula, and the big thing here is making sure your big arc and little arc are in the correct place in your formula. Let's take a look at some examples. We're going to do 3 examples here. Alright, so our first example we're going to have something that looks like this. Alright, we know this is 120 degrees, this is 10 degrees, and we want to find that angle x. Alright, again, remember, it's angle equals big arc minus the little arc divided by 2. So, what's our angle? X. What is our big arc? Our big arc is this 120. And this 10 is our little. So we're going to take 120 minus 10 on top and then divide it by 2. Since x is already all by itself, we can just use order of operations to solve. We can combine our like terms here on top, so x equals 110 divided by 2, and 110 divided by 2 is 55. So our x is 55 degrees. Alright, let's take a look at 2 other examples. Our next example, I'm going to put right here next to it. Okay, let's say we've got something looks like this. We have a tangent line that then intersects with a secant line. Alright, so our vertex is still on the outside of our circle, so we're going to be using this same formula. This time, we know that our angle in here, I'm just going to draw an arrow, our angle in here is 12 degrees. Let's say we're looking for this part, and we know that this is 82 degrees. Alright, so here's our small arc. This is our little. I'll put lit for little. And then this 82 is our big arc. 12 is obviously our angle, so we're going to have 12, our angle, equals our big arc, which is 82, minus our little arc, which is x, all divided by 2. Alright, so what we want to do is get x all by itself. First thing we're going to do is get rid of this fraction. Alright, so we're going to multiply by 2 on both sides. So we've got 24 equals 82 minus x. What would you guys want to move next? Okay, I think what a lot of people would commonly do is move the 82. And to move this 82, we have to subtract 82. And that means we are going to get a negative number. But it's okay, alright? Your answer is never going to be negative, but it's okay that we have a negative number right now, because 24 minus 82 is a negative 58, and this negative 58 is equal to a negative x. How would I get rid of this negative x? Divide by a negative 1. Because that gets rid of your negative. And that's going to get rid of your negative on the other side as well. So that means x is equal to 58 degrees. And that is your little arc in there. Alright. Our very last example. I am going to draw a circle here. And let's say this time we have 2 tangent lines. Alright? We're going to be looking for this angle x, and we know that this out here is 243 degrees. That's all we know. Alright? So, let's see if we can set up our equation with what we know right now. Okay, what is our angle? X. What is our big arc? Our big arc is this 243. This is our big. So 243, and we're going to subtract our little arc. This is our little. Do we have a number for our little arc? No, we don't. So I'm not going to put anything here yet, because I don't have anything, not even a letter or a variable. This is all divided by 2. Now, just for a second here, I'm going to forget about my angle, and I just want to find this little arc right here. We have a full circle, right? And if I know that this part of the circle is 243, how am I going to find the little part of the rest of my circle? Well, a circle has how many degrees? 360, exactly. So, to find our little arc, we are going to take 360 minus 243. So, our little arc is going to be 117 degrees. That's what I can put in here. All right. Now we can solve for our x. 243 minus 117 is 126, and when we divide that by 2, x is equal to 63 degrees. Alright, so again, this was a recap of notes that we've already learned earlier in the semester. If you have kept your notes from this semester and want other examples to look off of, those notes are the 225 notes that look like this in your binder or notebook, wherever you kept those. Alright, so that is it for today, and I will see you guys next time.